Our first video, our first substantive video this week is for me to just introduce you to this idea of categorical predictors. And so that's video 2. And this is going to be the first video where I do introduce some content. And the reason why I introduce content is it's a little bit easier for me to discuss content, or at least discuss these contrasts that we're going to talk about and categories with content-specific examples. So you'll have to forgive me, those of you who prefer cats over dogs. Well, you'll just have to create your own course. So that's going to be the nature of the content. Here I've got a very simple example where I have x. X is something that makes you happy, or so we hypothesize, and happy is a dependent variable. And if I plot happy with respect to x, you'll see here that the higher x is, the higher the more happy you are. And you can see here that I've already run this, and I want to do a linear model here, and you can see that I account for a lot of the variance because I only added 50% of the variance, but notice that I ordered my x variable, and that's for a reason. It just makes it easier to create categories. And then what I did was I plotted the effect or the relationship, and now I'm going to throw a line in, and that's our line of best fit for a bivariate relationship between x and happy. So x is something that makes you happy, and sure enough, it looks like it accounts for a lot of variance. But really, what x is x is an instantiation of a categorical variable. And it comes from a very simple idea that pets make you happy, but to different degrees. And x is really a continuous variable of dogness. So higher values mean the x is more like a dog. Cat lovers, again, can create your own course. So what I do is I created a variable called c. Excuse me. And c is, you notice now, the reason why I ordered my x is I wanted a little bit of control over this because I wanted dogs to be up top and cats to be on the bottom. So cats are below fish, fish are above cats but below pigs, pigs are above fish but below dogs, and dogs are, well, they get top billing. So what happens when we do this, you can see that dogs and do make us happier, because you can see here, look at that main effect. So C is our our dog category. And you have cats on the bottom and dogs on the top, just the way it should be. And then we do a linear model, and that linear model gives us this. And you'll notice that we, instead of having C as a predictor, we have C fish, C pig, and C dog. Okay, and each one of these is a category of C, but what's missing is cat. And if you take a look, and this is how we deal with categorical predictors in one of the ways. This is called dummy coding, which I'm going to go into great detail in the next video, or in one of the next videos. And you'll see here that this is what is called a contrast matrix. Okay, it doesn't mean that it's all of the data, it just means that this is the logic underlying the way we're contrasting these different categories. So you'll notice that on the top there are the new variables, fish, pig, and dog. And those are these are going to be the new variables that get created. Now, of course, they get prefixed in R with C. So it's C fish, C pig, and C dog. And these are the observed categories in the rows. So cat, fish, dog, and pig are our observed categories for our variable C. And you'll notice that if you're a cat, you get a 0, 0, 0. And if you're a fish, you get a 1, a 0, and a 0. And if you're a pig, 0, 1, 0, and then a dog, 0, 0, 1. All these represent is how the data will be recoded and created in such a way such that each of these predictors will be entered into our model as binary predictors. Okay, in this case, they're binary. They only get two values, 0 or 1. And so here there are 4 categories. There are K categories, which equals 4, and there are always going to be K minus 1 variables that come out of this type of contrast. Okay, so we've got K categories, 4, and K minus 1 variables that come out. Understanding this is important because we're going to talk about different numbers that go into this matrix that create different comparisons. And that's the reason why I'm taking a long time to go through this, because we're introducing a lot of different things, a lot of different operations, and these different operations lead to different interpretations of the results. So this is how we deal with categorical data or nominal level data, is we create comparisons of the different levels. Now you'll notice that just as a quick review, I started out with a continuous variable, x, and then I chopped it up into I chopped up a perfectly good continuous variable into 4 categories. Now, oftentimes when we're dealing with categories, we're dealing with things that are manipulated, like they got the treatment X or the treatment X2, or treatment A versus treatment B. Those are categories and they're distinct. And in this case, I created categories out of a continuous variable. So we got to be careful about what makes our category categorical. Okay, that here, these are differences of kind. And we'll discuss this later, because this is pertinent in terms of making comparisons that are interpretable. Okay, but for now, suffice it to say that I've created categories out of a continuous variable, and what I've said is my X variable is a measure of dogness. So higher levels means that you're more likely to be a dog, or X is more likely to be a dog. And because of that, what I've done is I've created cut points in my X, and then I've labeled them with categories, names. And things get a little bit more difficult when we start thinking about other variables that are relevant to our own research areas. But remember that you need to understand what the categories are and how you want to compare them in order for all of this material to make sense. Okay, so from this point forward, I'm going to assume everybody understands the example here, that dogs are superior to all other animals, and that dogs make us happier than everything else. From this point forward, we're going to move fairly steadily through different types of coding. Okay, so first I'm going to introduce the idea of the coding, how it's done, and then I'm going to run an analysis in a subsequent video and explain all of the parameters in both a bivariate relationship as well as a multiple predictor, or a MRC model. So stay tuned for fairly short videos that first document the type of coding, and then a second video that follows it up with interpreting the results. Stay tuned.